We live in an extraordinary time. For decades, we were confident, believing the universe had finally become understandable, even predictable. But now, that certainty is slipping away. Theories that seemed unbreakable are starting to crack. Data that once fit together perfectly now refuses to align with our familiar picture of reality. And the deeper we look into the cosmos, the clearer we hear a quiet whisper. You're missing something. Today, we might be standing on the threshold of a scientific revolution, one as profound as the discovery that the Earth orbits the Sun, or that our galaxy is just one among trillions. These moments are rare. Sometimes a century passes before the universe forces us to rewrite its rules. And it feels like that moment is now. For a long time, we thought we had a nearly perfect model of the cosmos. It started with the Big Bang, continued with the formation of the first atoms, included the birth of galaxies, stars, and planets. It accounted for dark matter holding galaxies together and dark energy accelerating the expansion of space. It seemed we had finally built a framework that described the past, present, and future of everything. But about 15 years ago, the first troubling signals appeared. Astronomers began discovering structures in space that, according to all our calculations, simply shouldn't exist. Giant arcs of galaxies, stretching more than 3 billion light, entire groups of quasars spanning 4 billion light, rings of galaxies 5 billion light-years across, and even a colossal wall nearly 10 billion light-years long, almost a tenth of the entire observable universe. According to our best models, structures on this scale are impossible. On scales larger than about 1 billion light, the cosmos should become smooth and homogeneous, like all the big structures have dissolved into the background. Yet observations show the opposite. Where we expect uniformity, we see monstrous formations, as if carved into the fabric of the universe by a gigantic hand. This isn't just a minor detail. It breaks the very foundation of cosmology. The idea that the universe is the same everywhere is our primary tool for understanding how it works as a whole. If that's wrong, everything we see might just be a local anomaly, like trying to judge an enormous cake by licking a single cherry on top. But that was only the first crack. A second one followed, and it is perhaps the most controversial issue in modern astronomy: the rate at which the universe is expanding. We've learned to measure this expansion rate with incredible accuracy. The problem is, different methods give us different answers. One method looks far back in time to the cosmic microwave background, oldest light in the universe. The other observes stars and galaxies that are much closer to us, here and now. Both techniques are extraordinarily precise and have passed countless checks. Yet they contradict each other, and this isn't a small disagreement. The mismatch has grown so large that the probability of it being a simple measurement error is less than 1 in a million. It's as if the universe, when asked how fast it's growing, is answering in two completely different voices. This has happened before in science. When Uranus's orbit didn't match predictions, we discovered Neptune. When anomalies appeared in Mercury's orbit, we developed general relativity. We are at another one of these turning points. Either we're about to find something new and invisible, or we'll have to rewrite our understanding of space itself. But the loudest crack of all came from the James Webb Space Telescope. Almost immediately after it started working, JWST discovered dozens of galaxies that are so bright, massive, and mature that they simply shouldn't exist so early in the universe's history. It found fully formed galaxies just 280 million years after the Big Bang. According to our models, it should have taken at least 500 million years for large galaxies to assemble. Even stranger is their maturity. These galaxies already contain heavy elements, which can only be produced by multiple generations of stars. For that to happen, stars must be born, live for millions of years, explode, scatter their material into space, and then that material has to come together to form new stars and planets. How could all of this happen in such a short amount of time? It is like walking into a kindergarten and finding a room full of adults who already have kids and grandkids. Something doesn't add up. Not in the timing, not in the logic, and there are other older problems too. The cosmos contains a strangely low amount of lithium, almost 3 times less than our theories predict. Dark matter behaves weirdly in the centers of galaxies, not matching our models. Some studies suggest dark energy might be changing over time, even though we assumed it was a constant. Even the cosmic microwave background, once our most reliable dataset, is now under scrutiny. It's possible that early galaxies were much brighter than we thought, distorting the picture we've been looking at. All of this could be a random collection of unrelated puzzles. Or it could be a sign that our picture of reality is long outdated. Some scientists are convinced we're on the verge of a revolution. Others say we just need more data, and everything will eventually fall into place. But the fact remains, for the first time in many years, we are honestly admitting that we don't understand what is happening. Our theories have once again proven too narrow, and the universe too complex. And that is a wondrous time to be alive, because a crisis in science isn't a failure. It is the first sign that we've reached the boundary of old knowledge and are standing at the door to something new. Scientific progress almost always happens in leaps. Long periods of calm are broken by sudden phases of confusion. When old ideas stop working, chaos takes over, and bold, almost insane hypotheses emerge. But it's from these moments that new eras of understanding are born. We may be living through exactly such a moment right now. And, strangely enough, that's a reason to be joyful, because the universe has become mysterious again. It's forcing us to ask questions, to doubt, to search. The more cracks that appear in our theories, the closer we get to grasping something far deeper. In the coming years, new telescopes, new dark matter searches, gigantic galaxy surveys, and improved measurement techniques might either fix the old model or shatter it for good. We might discover a new particle, a new force of nature, a new principle governing space and time. Or we might realize that the very concept of an expanding universe needs to be rethought. Whatever path turns out to be correct, one thing is clear. We are on the cusp of a new era of exploration, an era in which the cosmos is once again filled with mysteries, an era in which we may finally understand why the universe behaves as though it no longer likes our laws. Right now, we are listening as it whispers. Keep searching. And that is what makes our time so incredible, because in moments like these, humanity takes its greatest leaps forward. Thanks for watching. If you enjoyed this journey to the edge of our understanding, make sure to like and subscribe for more explorations into the great unknown.